Kia ora koutou, welcome to this next Chemistry Level 2 video. In this video we're going to be looking at the concept of the mole. So the mole is a really important concept for a lot of Level 2 standards and Level 3 standards, and then broader into chemistry. It's really important that we understand what this means. The mole is just a quantity of atoms. But before I go into explaining how we use this to do any calculations, I'll just go over a bit of an analogy that will hopefully make things a bit easier. So I've got 12 circles here. Let's say these 12 circles are eggs. So if somebody had 12 eggs, how would we refer to the number of eggs that they have? Well, what we would actually say is that they've got a dozen eggs. So we've got the term dozen is a word that we use to quantify 12. We don't say 12, we say it's a dozen. So the mole is similar to this. What we could do, so hypothetically, let's say we've got somebody with 12 eggs, we know they've got 1 dozen eggs. What say that person then got another 12 eggs? So we've got another 12 eggs here, a little bit smaller, make them the same size. How many dozen eggs does this person have if they've got all of these eggs here? So if they've got 24 eggs, how many dozen do they have? Well, we would know, just intuitively, we can work it out that they've got 2 dozen eggs. But let's look into that a little bit further and find out what maths we've actually used to figure out that this person has got 24 eggs. So to do this, we'll just define a few variables. So we'll say that E equals the number of eggs. So the number of eggs a person has, we'll use the variable E. Let's say that D, capital D, is the constant of a dozen. So 12. And we will say that a lowercase d is the number of dozens that a person has. Number of dozen eggs. So how can we use these variables to make a formula? So what we've done here actually is that we've said the number of dozen that a person has is equal to the number of eggs they have divided by the constant, which is a dozen, so divided by 12. So in this case, the person has got 24 eggs, and we're going to go 24 divided by 12, and that is how we've worked out that the lowercase d, the number of dozen that a person has, is 2 if they had 24 eggs. So what if a person had 124 eggs? So d would equal E divided by capital D, so we'll go 120, divided by 12, so the constant of a dozen, divided by 12, and that equals 10. So we can work out, and we could go on for a huge number of eggs that we wouldn't be able to very quickly work out just without using the maths. So that's a nice way to work out the number of dozen eggs that somebody has. Let's say that we've got so many eggs that we don't want to have to count every individual egg. But what we will say is that we know that a person has got size 7 eggs, for example. So let's say we've got a person with size 7 eggs, and they've got a certain number of size 7 eggs. Because the size of the eggs are all the same, we could probably work out the mass of the eggs per dozen. So we're just, excuse me if this is getting too theoretical, but let's say we've got a dozen eggs, and a dozen eggs weigh 600 grams. 600 grams per dozen of size 7 eggs. So if we know the mass per dozen of a certain size of egg, and we know how many, and we know the mass of eggs that a person has, then we could still work out the number of dozen eggs that they have, don't they? So we could, instead of saying that the number of eggs, that the constant of a dozen, and we had the number of eggs, we could change this to being, let's say, the mass of the eggs. So this could, we're going to do it slightly differently. We're going to say that E equals the mass of the eggs, and we'll say that D is the constant of the grams or kilogram per dozen for that size of egg. So we'll say that a person has got 300 kilograms, 3 kilograms of eggs, and they're all size 7 eggs. Then we can work out how many dozen eggs they have. So we'd use the same technique. So we're going to go the number of dozen that a person has equals the mass of eggs that they have. So in this case, well, why don't we change it? Instead of E being the number of eggs, we'll say that this is actually lowercase m. So the number of dozen equals the mass of eggs that a person has divided by D, the number of kilograms per dozen. So that's going to equal the mass if somebody had 3 kilograms divided by the kilogram per dozen. So in this case, it's 0.6 kilograms. 0.6 kilograms, so we're going to end up with 5 dozen. So if we knew that somebody had 3 kilograms of eggs, they were 600 grams per dozen, then they have got 5 dozen eggs. So I'll cut to the chase about the mole now. So the mole is, just like the dozen, it is a number to describe, well, it's a set number for a number of atoms. The tricky part is that the number is 6.02, easy enough, times 10 to the power of 23. So that's a huge number. We're not going to, if we wanted 1 mole of iron, for example, I'm not going to be able to count 6.02 times 10 to the power of 23 atoms to see that I've got a mole. So we're actually going to need to use the concept of grams per mole. And we can find this value by looking at our periodic table. So it's actually the mass number, so the number that's below the symbol, our element symbols on the periodic table, is the grams per mole of that particular element. So if we stick with iron, what we call this is the molar mass. So the molar mass is given the symbol capital M equals the molar mass. So that is grams per mole. So how many grams of this particular element? So how many grams of this element means that we've got 6.02 times 10 to the power of 23 atoms of iron. So we write it out. We often do it like this with a capital M, and then in brackets you put the symbol of the element. And for iron, you just look on the periodic table, and it's 55.9. 55.9 grams per mole. So what we can do is use, similar to our formula there, we can work out, if we've got a certain mass of iron, we can work out the number of moles that we have. So I'll just define some more variables. So we've got N equals the amount of mole. So that's like the number of dozen, the amount of moles. We can do it like that if we want. Often it gets, often we have this abbreviated to just MOL. We don't have the E there, but we'll say amount of moles. And then the mass is, lower m is the mass of our substance. So that we would measure it in grams. So, and the formula that we use is the amount of, or the number of moles of a substance. The N, we normally refer to that as the amount. So if we say, what is the amount of iron, we would give an answer in moles. So the amount of moles of a substance is equal to the mass that we have of that substance divided by the molar mass. So the molar mass being the grams of that substance that we need to make 1 mole. For some reason, I've just put just a lowercase m there, but I actually need to go grams per mole like that. So let's say I had 5 grams of iron. What would be the amount of iron that I've got? So we would need to go 5. Just doing this on a calculator to go through. 5 divided by, so we put 5 into there, divided by the molar mass, which is 55.9, and we get 0.0894 mole. So I'll write that out. So if N equals, so we've got 5 grams divided by the molar mass of 55.9, 0.9 grams per mole. We cross these out, and then that's going to end up on the top. So that gives us a clue as to what the units are. So we're going to have 0.089894, rounded to 3 significant figures, and then the units are simply mole. So instead of saying 0.0894 dozen, we've got 0.0894 mole. What we can also do is use this if we've got the certain mass of salts, for example, or a compound. We need to tally up the all of the atoms within a compound, and then that's how we work out the molar mass of the compound. So we'll do a quick question there. So I know that this video is dragging on a little bit, but let's say how many mole do we have of NaCl if we have 10 grams? So to work this out, we use the same formula. So the amount of mole, the N, equals the mass divided by the molar mass. So to find the molar mass of NaCl, we need to tally up the mass numbers of each of the atoms in there. And we just do one of each because there's only one sodium and one chloride. So for sodium, we've got 23 plus the chlorine, which is 35.5. 35.5, so the molar mass of sodium chloride is 23 plus 35.5, so we've got 58.5 grams per mole. 58.5 grams per mole. And so we can now just put this into the formula. So the mass that we have is 10 grams, so the amount equals 10 divided by 58.5, it equals 0.171 mole. So 0.171 mole. So we could work out the number of atoms that we actually have in 10 grams of sodium chloride, or the number of sodium chloride compounds that we have by timesing this number by 6.02 times 10 to the power of 23. That would give us an approximate number of atoms that we have in there, or number of compounds. So that's how we work out the mole and the amount of mole that we have of a substance. I hope this video has helped. I hope the analogy hasn't just confused things and has actually helped you be able to work it out. The best way is just to practice. So if you find some questions in your textbook and practice working out the amount of mole, you'll get there in no time. Thanks very much for watching. Like and subscribe for more Chemistry Level 2 videos.